where experience comes in. Sammy James is dialed right in. He's going to the bank. He's challenging Longshot right now.
Big machines and big dreams. Vehicule reawakens an era of unmatched greatness.
This is offshore powerboat racing at its best.
Step into the world of offshore powerboat racing, where big machines weren't just about speed, they were about spectacle. This was the golden age when offshore powerboat designers and engineers had a singular goal: to build the most daring, high-performance machines on the water. The history of offshore powerboat design is a fascinating journey marked by innovation, competition, and a relentless pursuit of speed and efficiency on the water. Scaffy blue boats, developed in Naples, Italy in the post-World War II era, were used to smuggle cigarettes across the Gulf of Naples and beyond. These sleek, blue-painted boats were designed for speed and camouflage, painted blue to blend with the night sea. These boats were typically piloted by an experienced motorboat driver and carried up to 1,000 kilograms of cigarettes per trip. The Scaffy Blue were key to a smuggling economy that helped support many families in Naples by transporting blondes, a local term for cigarettes. Often, when spotted by Italian authorities, these boats would engage in dramatic, high-speed chases across the Gulf. Some even used powerful water cannons or tried to snag the Scaffy Blue's propellers to stop them in pursuit. The boat's design and performance were essential in this operation, allowing smugglers to escape and deliver their goods back to port for local distribution. The Scaffy Blue boats marked a transformation of recreational and commercial vessels into high-performance machines suitable for open waters. Initially, many of these boats had displacement hulls, which are rounded and deep, allowing for smooth movement through waves rather than over them. The boats typically measured 20 to 30 feet and were often crafted with wooden materials such as mahogany and teak, due to their durability and availability in European boat-building hubs like Italy and the UK. This construction was optimal for early offshore races, which demanded stability more than speed in choppy waters. By the 1950s and 1960s, advancements were made towards semi-displacement and planing hulls, which featured flatter designs and enabled boats to reach higher speeds by skimming over the water's surface. These early offshore racing boats often maintained the semi-displacement hull shape, allowing them to carry extra weight, an asset for longer races. The pioneering Deep V hull, invented by Ray Hunt in the 60s, was a major turning point in offshore racing, providing both speed and stability at sea. In the summer of 1958, Richard was sailing in the America's Cup trials in Newport, Rhode Island, when in the whitewater, something caught Dick Bertram's eye: a 23-foot runabout navigating through the heavy chop with ease. This boat, owned by New England boat designer C. Raymond Hunt, featured a unique Deep V hull design, something unheard of at the time. Taken aback, Bertram believed this smooth-riding, efficient design could be the answer to a more comfortable, functional pleasure boat. He immediately commissioned Hunt to build a similar boat for his family, and by early 1960, a wooden Deep V 31-foot boat was complete and famously dubbed Moppy. When powerboat racing partner Sam Griffith took a test ride on the new Moppy, he was eager to enter it into the 185-mile Miami to Nassau race. Griffith believed this new hull design could lead the way to victory, even in the heaviest of seas. On race day 1960, howling winds and monstrous seas were no match for the revolutionary new hull design of the Moppy, as it led the entire race and crossed the finish line in a record-breaking to-the-minute 8 hours. The Ray Hunt design proved to be everything Richard Bertram had hoped for, and the boating world immediately took notice. This innovation, combined with lighter materials such as fiberglass and aluminum, laid the groundwork for the high-speed powerboats that came to dominate the sport. When planning the proportions and weight distribution of an offshore powerboat, several critical factors must be considered to ensure optimal performance and stability. One of the primary elements is the hull design and shape, which significantly affects how the boat interacts with water at various speeds and conditions. Proper weight distribution is essential for maintaining balance and preventing capsizing. Strategically placing heavy components such as engines and fuel tanks helps achieve a balanced center of gravity, enhancing stability during operation. The placement of power and propulsion systems also influences weight distribution. For instance, surface drives can enable better weight distribution towards the transom, while traditional inboard engines may require different configurations to optimize performance. Material selection plays a vital role in the overall weight of the boat. Using lightweight materials such as fiberglass and carbon fiber can enhance speed and maneuverability, whereas heavier materials might provide increased durability but could compromise performance. Additionally, the intended use of the powerboat, whether for racing, recreational cruising, or commercial purposes, will dictate specific performance characteristics and influence design decisions regarding proportions and weight distribution. Finally, environmental conditions are a significant factor in design planning. Offshore powerboats must be capable of handling specific sea states, so designers must consider expected wave heights, water types, and weather conditions to ensure optimal performance in their intended operational environments. These interconnected factors guide the design and engineering of offshore powerboats, ensuring they can meet the demands of high-speed performance in challenging marine environments. Offshore powerboat engines are specifically engineered to endure the unique challenges of high-speed marine environments. They are built with durability in mind, utilizing corrosion-resistant materials such as stainless steel and high-grade aluminum to withstand the harsh effects of salt water, humidity, and high vibrations. These engines typically employ closed cooling systems that use seawater to manage engine temperatures, a critical feature given the intense heat generated during high RPM operation. This design contrasts with standard automotive cooling systems, which rely on a conventional radiator setup. Offshore engines are designed to produce high horsepower and can operate at elevated RPMs, allowing for rapid acceleration and high-speed performance on the water. Additionally, they are often paired with specialized propulsion systems like surface drives or stern drives, which enhance speed and maneuverability by taking advantage of water dynamics.
Tell us the advantages of going with a naturally aspirated engines.
Well, the main reason we went with naturally aspirated engines is because with a naturally aspirated engine we have a response that is much quicker and allows us to run stronger in rough water. With a supercharger or a turbocharger, you have what we call turbocharged lag, and which means the turbocharger takes a few seconds to come back in and allow the engine to recover.
We decided to go with the superchargers as opposed to turbochargers because it seems like they're more adaptable to offshore. It's much better throttle response. Turbos take quite a while to build up boost, whereas supercharger has immediate boost. It's a direct drive supercharger system. You have throttle response right away, whereas with turbochargers, you got to wait for them to spool up before they start making boost.
The system works really by taking the exhaust gases and running them through a compressor, and from the compressor increases the pressure on the air inducted into the engine. The benefits are that the engine lasts longer and runs smoother, is more happy with itself, and produces a very long torque curve, which gives us a tremendous acceleration.
The great thing about supercharging over turbocharging is that the throttle response on the supercharger, because it is belt driven, it is driven by the engine, is instant. It's neck snapping acceleration on tap whenever you want it. Where a turbocharger, you've got to wait for the engines to spool up a little bit.
Watch us in the turn. We don't have any turbo lag.
Maintenance for offshore powerboat engines is rigorous, as they require more frequent servicing to maintain reliability under extreme conditions. Regular rebuilding or refreshing is necessary to ensure optimal performance and longevity. Overall, the design and engineering of offshore powerboat engines focus on maximizing performance, durability, and reliability, enabling them to thrive in the competitive and often brutal conditions of powerboat racing. Racing propellers are crafted with specialized features to maximize speed and handling under high-intensity conditions. These propellers are typically made from high-strength, corrosion-resistant materials like stainless steel or nickel aluminum bronze, allowing them to withstand the stress of high RPMs in extreme marine conditions. The blades on racing propellers often feature a unique shape, such as a square trailing edge and a thin leading edge, to reduce drag and increase efficiency. This design helps minimize the propeller's contact with water, making it more efficient at high speeds when combined with surface-piercing or partially submerged drive systems. Adjusting the number of blades also affects performance. For example, fewer blades reduce drag, while more blades improve grip, especially in turbulent waters. Racing propellers often employ heavy cupping, a slight curl at the trailing edge, to improve thrust by increasing the effective pitch and supporting smoother high-speed operation. Additionally, CNC machined propellers allow for precise customization of parameters like pitch, diameter, and rake, which influences lift, acceleration, and overall handling. This customization is crucial in adapting to different race conditions and boat types, whether for straight-line speed or maneuverability.
How fast can a boat go in rough water and keep its crew in one piece? When it all began back in 1956, of the three basics, man, engines, and hull, only man seemed ready. The engines were for the most part converted auto power plants. The boats were at best rough riding when they didn't break up. Now we have plenty of engine power, and the hulls are in the 80-mile-per-hour class. Now we worry about man. The front runners play a nautical Russian roulette, traveling so fast they constantly court disaster. For the past 3 years, the top engine used by the ocean racers has been the Mercruiser stern drive. Boats powered by stern drive inboards win most of the big races.
The stern drive, also known as an inboard-outboard I/O motor, was invented by American engineer Charlie Strang. While working for Outboard Marine Corporation, OMC, in the late 1950s, Strang conceptualized a hybrid engine that combined features of inboard and outboard motors. Strang's initial designs featured an engine mounted inside the boat, connected to an outboard-style drive that exited through the transom. Strang's idea caught the attention of Jim Wynn, a marine engineer and racer, who developed and patented the concept in 1958. Wynn's design improved on Strang's initial concepts and became the foundation for the modern stern drive. Volvo Penta later licensed the invention, launching the Aquamatic in 1959, which revolutionized the boating industry by offering a powerful, efficient propulsion system with the handling of an outboard and the durability of an inboard engine. Carl Kiekhaefer was the owner of Kiekhaefer Mercury, later Mercury Marine, and also a two-time NASCAR championship car owner. In 1957, Kiekhaefer introduced the Mark 75 motor, the industry's first six-cylinder 60-horsepower outboard motor. Two Mark 75 motors set an endurance record by running for 34 days, 11 hours, 47 minutes, and 5.4 seconds, non-stop, and over 25,000 miles. The motors were refueled on the run and averaged 30.3 miles per hour. In 1961, Kiekhaefer used his NASCAR and boat engineering skills to develop the 100-horsepower stern drive engine, now known as Mercruiser. Fabio Buzzi, an Italian engineer and offshore powerboat racer, was a true innovator in high-performance boat design, significantly advancing the industry with his contributions. Buzzi's early work in the 1970s led to the creation of his company FB Design, which focused on both racing and commercial high-speed vessels. Notably, he was the first to introduce Kevlar into boat hulls, vastly improving their durability and speed. His innovative hull designs, which featured unique steps and specialized rudders, allowed boats to plane more effectively at high speeds, a concept that became fundamental in modern powerboat racing. Buzzi's collaboration with FPT Industrial led to innovations like electronic variable geometry turbochargers, a single direct cooling system, and specially designed steel piston engines. These advancements contributed to numerous world championships and speed records over his career, including a 2018 Guinness World Record for diesel-powered boats with a speed of 156.58 miles per hour. His work remains impactful across racing, recreational, and military boats due to these transformative design and engineering achievements. Stepped hulls were introduced to improve the speed and stability of powerboats by creating specific lift points on the hull, reducing drag and enhancing efficiency. These steps, or breaks along the hull, add a second or even third point of lift, which keeps the boat more level as it moves across the water. By reducing the hull's contact with the water, steps decrease resistance, allowing the boat to reach higher speeds with less power and improve fuel efficiency. Steps need to be meticulously placed to prevent stability issues. If placed incorrectly, they can destabilize the boat, causing phenomena like chine walking or issues during hard turns. These developments, combined with powerful engines like the Mercury V8, propelled the sport into a new era of speed and capability, allowing for both recreational and competitive boats that could reach unprecedented speeds and performance levels. The Arneson surface drive was invented by Howard Arneson in the early 1980s. It revolutionized high-speed marine propulsion with its innovative design, which allows the propeller to operate partially above the water surface, reducing drag and increasing efficiency. Unlike traditional submerged propeller systems, the Arneson drive positions the propeller shaft at an angle, enabling the propeller to skim the water surface. This design reduces friction and allows for greater speeds, especially beneficial in offshore powerboat racing and high-performance marine applications. The surface drive also offers enhanced maneuverability and fuel efficiency, as the propeller's exposure minimizes resistance, requiring less power to achieve high speeds. Additionally, Arneson surface drives are adjustable, which allows for trimming the propeller angle for optimal performance in various water conditions. These features made the Arneson drive popular in racing and among military and commercial applications where speed and efficiency are critical. The shift from deep V hulls to catamaran designs in offshore powerboat racing introduced a series of technical advancements that dramatically enhanced speed, stability, and handling on open waters. Early offshore racing boats were primarily deep V hull designs, celebrated for their ability to cut through rough waters. Invented by Ray Hunt in the late 1950s, the deep V hull had a sharp angle, or dead rise, that sliced through waves, providing a smoother ride in choppy conditions. This made it ideal for early offshore racing, where stability and durability were prioritized over speed alone. In the 1980s, however, catamaran hulls began to reshape the field, appealing to racers aiming for maximum speed. Unlike deep V designs, catamarans feature two hulls with a narrow tunnel between them. This tunnel traps air, which creates lift and reduces drag as the boat accelerates. This aerodynamic lift, known as tunnel effect, allows the catamaran to skim over the water, carrying up to 35% of the boat's weight on the air cushion, significantly boosting speeds by reducing the hull's water contact. Catamarans, like those from builders such as MTI, pioneered by offshore powerboat experts like Randy Sissom, can reach speeds up to 30 miles per hour faster than V-hull boats of similar power. The unique characteristics of catamarans do, however, come with some challenges. While they excel in smooth and open water, they can be less stable in rough seas, as the twin hulls tend to follow wave contours, resulting in more pronounced rolling than deep V hulls. Over time, engineers have improved catamaran designs, integrating enhanced weight distribution and aerodynamic features to increase stability in challenging conditions.
Look at the arm of Bob Sassetti, the magic throttle arm.
on, Phil. Show us how it's done, Bob.
In offshore powerboat racing, the throttleman, not the pilot, is responsible for the boat's speed and maneuvering, managing both throttle adjustments and the boat's stability over challenging waters. This demanding role requires navigating the sea's shifting conditions and making instantaneous decisions to control power distribution and balance. The pilot's role, while significant symbolically as team leader, doesn't involve as much direct control during the race. In this setup, skilled throttlemen like Steve Curtis, Bob Saxeni, and John Tomlinson often led boats to victory, while notable pilots, including celebrities and high-profile owners, took on more public-facing roles. Curtis, for example, used his expertise to balance speed and safety across some of the sport's roughest races, leveraging decades of experience to secure championships and elevate the sport's visibility.
Let's go racing.
As engineers refined the technical power and performance of offshore racing boats, others brought cultural prestige and public fascination to the sport, transforming it into a glamorous, high-speed spectacle. Celebrities like Chuck Norris, Don Johnson, and Kurt Russell played an instrumental role in popularizing offshore powerboat racing during the 1980s and 1990s. Their presence added a major glamour factor, attracting significant media coverage that brought the sport to a broader audience. Johnson, the star of Miami Vice, was especially influential. He became a serious competitor and won the World Offshore Championship in 1988. Entrepreneurs like Al Copeland and Donald Trump also boosted the sport's profile. Copeland, a businessman and competitive racer, sponsored and drove high-powered boats, while Trump hosted racing events in the late 80s to draw attention and add excitement to his properties, such as Trump Castle in Atlantic City. These high-profile figures helped to elevate offshore racing from a niche sport to a televised spectacle, contributing to its golden age when massive investments and media attention were common. Tulio Abate, an Italian powerboat racer and designer, brought significant innovation to offshore powerboat racing, transforming it into a sport with international appeal. His Tremezzo shipyard on Lake Como became a hub for high-performance boat design, with Abbate pioneering the use of fiberglass and sleek, high-speed hulls that made his boats renowned globally. His vessels, often dubbed the Ferraris of the seas, gained recognition for their advanced engineering and became popular among elite racing circles due to their durability and speed. Abbate's contributions to boat design, such as his work on the Offshore 36 and later collaborations with renowned designers like Giorgetto Giugiaro, helped raise offshore racing standards and attracted a new wave of enthusiasts. Abbate's influence extended into the celebrity world, where he introduced notable figures from Formula One and beyond to offshore racing. His client list read like a who's who of sports and entertainment icons, including F1 drivers like Niki Lauda, Michael Schumacher, Bernie Ecclestone, Nico Rosberg, and later Ayrton Senna, for whom Abbate designed a special boat model in collaboration with the Ayrton Senna Foundation. Other prominent names who joined Abbate in offshore pursuits included soccer legend Diego Maradona and tennis star Björn Borg. These celebrity endorsements brought widespread visibility to offshore racing, establishing it as a sport associated with luxury and high-speed glamour. Entrepreneurs like Don Aronow and Tulio Abate were pivotal in transforming offshore powerboats into desirable lifestyle objects, blurring the line between high-performance racing and luxury design. Aronow, with his brands such as Cigarette, Donzi, and Magnum, created sleek, powerful vessels that became synonymous with wealth, status, and adventure. He founded these iconic brands along Thunderboat Row in Miami, which became a hub for racing enthusiasts and celebrities alike. His boats drew attention not just for their speed, but also for their sleek, stylish aesthetic, attracting a clientele that included heads of state, celebrities, and high-profile entrepreneurs. These visionaries transformed powerboat racing by creating brands that enthusiasts and casual boaters alike wanted to own and showcase, effectively blending the thrill of racing with the appeal of luxury.
The sea has flattened out a bit. It does that sometimes when darkness nears. The water is filled with reflections and strange abstractions of light colors. Everything is wild and unreal. The boat, like a giant sea chariot of fiber and metal, runs screaming across the shining ocean, reaching sunward and flat out. And these are moments when an ocean racer feels completely free. And suddenly it's worth all the expense and punishment. This is the reward of true adventure. And if you're lucky, all your yesterdays get mixed up with tomorrows. And you're alone and free.